Good morning, everyone. My name is Marika. I will be moderator of today's meetup. We want to welcome you again to our Grid Dynamics Dynamic Talk. And today we will listen our technical topic from our senior staff software engineer, Udaya Thalabattula, with the topic Marching Towards Ideal Microservices. But before the start, I want to share some rules and tell you more about our company. During talk, you can ask questions via Zoom chat. Please check that messages in the chat will be visible for all the participants. After the report, the speaker will answer them. Also, you can unmute your microphone in the end, in the last Q&A session, and ask questions by voice. But please check that your microphone is muted during the talk, not to distract our speaker. Let's talk about grid dynamics, as we are also waiting people to join. Grid Dynamics is a leading provider of technology consulting, engineering, and data science services for Fortune 1000 corporations from financial, technological, and retail sectors. It has been operating since 2006 in headquarters in California and has development centers in the United States, Eastern and Central Europe. As for today, Grid Dynamics brings together more than 4,000 engineers in 13 countries all over the world and continues to grow steadily. Grid Dynamics is a NASDAQ-listed public technology service company with core expertise in big data, data science, machine learning, i.e. scalable omnichannel services, DevOps, and cloud enablement. Here you can see some of our clients in different sectors. There are a lot of well-known companies that we are working with. And if you want to know more about our company or join us, please find more details on our career website. You can scan QR code now or share the link after our career with dynamics.com. Also, if you are interested right now, you can send your CV on email that you can see at the slide. So thank you again for listening about our company. And now I'm inviting our speaker to take a virtual microphone, Udaya.
Thank you, Marika, for giving a nice introduction about our company, Grid Dynamics. Hi, guys. Good morning and happy Saturday. Let me share my screen. I hope you will be able to see my screen.
We can see. Perfect.
Thank you. Hope you all had a great Friday yesterday. And yeah, so today's discussion, we're going to discuss about marching towards ideal microservices. And this is the first session for a series of sessions we planned here. And in this session, we're going to talk about, first let me introduce myself. My name is Udaya Thalabattula. My last name is kind of hard to pronounce. You can call me Uday or Udaya. Anything is fine. I have around 13 years of experience in building applications in Java. And from past 3-4 years, I was into building mostly microservices and cloud native applications. That's pretty much it about me. Let me go through the agenda. And here is our agenda. So first, we're going to talk about overview of monolith, because we need to talk about why. Before introducing microservices, we need to know why it needed in the first place. And so that we need to talk about the monolith and its shortcomings. And again, we need to talk about the service-oriented architecture. And then we'll be talking about evaluation of microservices and their benefits. And once everything is done, we need to talk about, is it the silver bullet solution for each and every problem we're going to solve? And finally, we're going to discuss about their characteristics and with the Q&A. And you'll have time to ask any questions or the chat or voice, as Marika told. Yeah. So why we need to discuss about monolithic architecture is in place, because if you need to understand what is really a microservice and what are the benefits and all, we need to understand the factors what caused the existence of microservices. So we need to hop into a time machine and go back to the olden days and figure out what really the architectures were there at the time. So back in 1990s, mostly, there was this monolithic architecture in place where all the components, like user interface, which displays some user interfaces components, like some UI elements, and the business layer, which talks about maybe some APIs to pull the data from the backend or do some business logic, and the data layer, which talks to database and persist or retrieve the data. All these components are tied together in a tightly coupled system. And this system worked well until it is so small. Everything, you don't see any issue until it's small, and you don't see any issue of scaling and all. But as soon as you keep adding complexity of features into that application, it's really hard to do some things that we're going to talk about, what exactly those things will happen and the disadvantages of monolithic. Okay. And let's try to do some examples so that you can easily understand what's the shortcomings of a monolithic application really. I think I'm pretty much sure you must have already placed an order in one of the food ordering websites like apps like Swiggy or Zomato. So I'll take that example so that everyone would be really relate to it. So whenever you're trying to order food in the Swiggy or Zomato app, you would be opening up the app, looking for the restaurants and checking their menus, selecting the corresponding food you wanted to buy, and you place an order, and one of the delivery agent will pick up a notification that he needs to pick the order, and he will be delivering the order at your house. So these are a lot of functionalities are happening all the time synchronously, sometimes asynchronously. So assume that if that is a system, if they're built on monolithic architecture, right? So the monolithic architecture, as everything is tightly coupled, all the functionality, whatever I spoke about till now, everything will be pushed into source code. Means anything, whatever the right developer writes a code, it needs to push somewhere, maybe GitHub repo or GitLab repo. So monolithic architecture lives on a fund of having a single source code repository. So assume that I have a different functionalities of maintaining orders, maintaining restaurant information in their operating hours, and maintaining delivery agents and notifying them regarding the orders we receive, and notifying the customers as soon as the order is placed or it's about to ship. So a lot of functionality will be maintained like there. So everything will be going into the single source code repository, and assume that we have 3 different teams for each and every functionality. Maybe order management team is there, consists of some developers and QA and some business analysts and all. And they're all working on only the functionality for order management. And similarly, restaurant and delivery management team also working together on their corresponding functionalities. And if they're working, collaborating and each other on the same time, producing different features into the production. So you might, if you're developers, and you might know that if you are trying to push code changes on making the code changes in a single file, you might see that midge conflicts will happen. And that's kind of inevitable, because someone might changes the same code, and you're trying to pull the changes and push the changes again. That kind of cause a lot of issues again. And that's one thing that will cause some time of at least the production delay or the deployment delivery time and all. And because of a single source code repository we have in the monolithic, we also used to have one deployment pipeline, which needs to run the builds on each and every code change needs to be pushed into the source code repo. And because of the one deployment pipeline, it will take a lot of time, because if you want to run a build, it needs to build an image, it needs to prepare an image it needs to be run in the production. And if multiple developers are actively working on similar changes and pushing around 20 to 30 commits in a day, so deployment pipeline has to work a lot. And also because of the large code in a single source code repository, the build time will also take more time. If you want to test some changes, you need to wait a lot more time in order to properly test your changes. And it needs to be deployed into the corresponding environment as well. So a lot of turnaround time would be there for the developer and the QA to verify their changes as well. And coming to the QA part here, so a QA engineer would call it any functionality, any app would be reliable only once she or he, once they validated the functionality, everything, and making sure everything is full of zero of bugs. But when they can say that, when they're perfectly tested everything. But if there is such large functionality of order management, restaurant and delivery and all, so they might need to go through each and every functionality whenever they're trying to validate. Like assume that if I'm a developer, I'm going to make a changes on order management. So I need to let the QA know that I did only change the order management functionality. I didn't touch any part of shipping functionality, I didn't touch any part of notification functionality. If you have any QA in the call, they wouldn't agree with me, because whatever the developer says, QAs always don't agree. So they'll need to verify that whether, okay, whatever Udaya is saying, I need to make sure that he didn't touch anything. So they need to, their boundary of area, like they have to cover a lot of area in order to make sure they're delivering a reliable product to the production. So, so monolithic at first place works well if it is small, until it's small. But as soon as you're adding complex functionalities, because of its nature, it's going to evolve and erupt. So let's talk about at least what are the advantages first, and when we're gonna need a monolithic in place. So as I told you earlier, it's simple. It's so simple. If you're really starting a new project, and if you don't know what architecture to pick, definitely go for monolithic, because it's so simple to develop. You don't have to, and all of the interactions between your services, like if UI needs to interact, yeah, I can call the service. If backend service needs to call DBS, I can call there itself, because in a monolithic architecture, your web server and your DB server and everything, it kind of closed together, maybe in an on-premise environment or somewhere in the kind of closed in a data center kind of thing, kind of distributed in nature, but not in a wide distributed thing. And it's easy to make radical changes, means because it's so small, until it's small. If I need a new functionality needs to be developed and deployed to production, means I need a faster market time. Definitely, yes. I can make the code changes. It's so simple because I know what I'm making. And it's straightforward test, because QAs would know that what they're really testing, and the deployment pipeline is small enough so that it knows what exactly it's building out, what Artifactory dependencies it needs to inject into the jar or what it's building. And if it's small, developers, if they're troubleshooting any issue in the corresponding environment, maybe in production or in QA, it's easy to debug for them. Like they can, because debugging is really a hard thing if it is so complex. So the bottom line is, if you're building something small or less complex project, then go for monolithic until it's small. But what are the disadvantages? Why we monolithic didn't succeed in all the times? Like, because people started using it and they keep on adding more functionality to the app as the time passes. So you can't hold it with a larger functionality. As I explained in the previous diagram, if it is becoming larger, more and more teams are getting added and more teams are adding more functionality to the application. You don't have control on that application itself, because developers would tend to have understand each more functionality. QS need to verify a larger area of QA coverage and all. So, if it is complex enough, then development is really also complex, because I told you the build times will take time, and the validations will also take time. Whenever you're touching a single piece of code, you need to make sure that you're not breaking any existing things also. And then also that writing the integration test cases or unit test cases are also kind of difficult, because you need to understand the entire system. Then only you can write the proper unit test cases to make sure that your code is not breaking anything existing. And the scalability here. So what is really scalability means? If you have built an app and it's working for 100 users, and if you're expecting 1,000 users at that time, is it your app with one set of instance, like one DB and one web server, if it is able to survive that load, service that load, can it service 1,000 requests? Can it service 10,000 requests? If it's not, if you have one more set of the same set, one more web server, one more DB server, maybe one more SMTP mail server and all, if you have that set, maybe with 2 instances, can we survive that load? Maybe if you're scaling up the instances, number of instances of web and service, this DB and all, then at that time, if it is able to service the request, then we can call it as a scalable application. But with monolithic, we can scale that, but to some extent, because we are acting in a proactive way. We don't know when the traffic is going to hit. So we need to know about when we are expecting a traffic. Like, assume that if I'm Amazon and if I'm going to build launch a sale like Amazon Big Billion Day sale kind of thing, then I know that definitely I would expect some more load. Then maybe I will prepare my instances to be, instead of 1, I'll make it 100 in order to cater all the load service requests. But again, with monolithic, scalability is problem in this case also. Like, assume that some marketing team wants to send a notifications, marketing promotional emails or push notifications to all the users. So only the one SMTP server might not be good enough to scale all the requests, like service all the requests. So then in a monolithic architecture, can I scale only the SMTP part where I don't need to scale the DB, I don't need to scale the web server, I just need to scale only the part of SMTP. Can we do that? No, it's not, because it's so complex that if you want to scale, you need to scale entire. Maybe the vertical scaling is kind of possible. Maybe you can add some CPU or RAM into that, but it's not, you can't really add one more SMTP server and load balancer. It's kind of difficult in, it's possible, but it kind of takes a lot of time, a lot of configuration place, a lot of manual interpretation needs to be there in order to achieve that scalability. And you can't call it as a real-time production thing, because when in real-time production, everything is so fast. Service requests and traffic load, it's kind of truly dynamic. So you need to have an app that comes to all these issues. And the third thing is reliability. So we explained earlier in the previous slide, when we call reliable is nothing but when QA is saying that, yes, it's soft, no bugs, it's working as expected. Even if we are getting more number of requests also, our app is able to service all the requests. Then I can call it as reliable. But the path towards reliability depends upon how much easier it is to test, how much easier to debug. Are we getting proper alert system in place if something is bad is going to happen? And what if something goes down? Are we able to recover from it without any issue? These are all parts comes under reliability, and it's monolithic. Is it kind of everything is in one system? If anything goes down, it's going to affect a lot. I assume that if I'm going to some changes and maybe I'm going to deploy my order management code into production, and that caused I didn't write the right code, maybe that could impact all entire the backend service, entire business layer. So that shouldn't happen, because no one did really bad changes on notification functionality and our inventory functionality. Those shouldn't affect when only order management is really in effect. But everything is tightly coupled here, so that's in stake. And definitely barrier to technology adoption. Like I'm not advocating for Java. Like assume that if someone did really good Spring Boot application or Java application, my monolithic application, right? And Java can't do anything, like anything and everything. Like there are some limitations to Java also. If you go with Spring Boot, there are startup times are really high. And if you want to build some CLA like applications, maybe Go language would be good one. Or if you're building some data science based applications, models and all, you would pick Python. But if you're building a monolithic application, you're confined to pick only one technology, because you can't do experiments with it. So that if I can build a notification service with some language, if I can build order management service some language, you can't do that because everything is tightly coupled. You need to pick only one language and you need to go with it. And the deployment, as we discussed earlier, only one pipeline is there. All the button will be going into that. If teams are getting bigger, and then again, it needs to work hard, and the deployment team also, you need to work hard to reduce the deployment time and all to make sure the turnaround time would be less. And as of now, it's everything is single and complex. If anything bad happens, the entire system would be kind of in stake issues. So that's where, with all these disadvantages in place, definitely we need some kind of new architecture. We need to evolve from monolithic, and that's where the service-oriented architecture is in place to solve the disadvantages or shortcomings of monolithic. And service-oriented architecture follows this kind of architecture. I'm not going to go deeper into it, but I'll give you a brief overview of how service-oriented architecture really works. So what service-oriented really addressing the problem is, if you have a complex functionality, if teams are getting bigger and bigger and adding more functionalities, as I'm making the changes and pushing them into a single source code base, is just causing all the issues. So then let me do one thing. Let me divide the functionalities, like entire functionality of code into chunks. so that I can maintain them. Each team, like order management team, if I can divide the functionality of order management, okay, maybe order management team is the responsible for to handle only the order management stuff. And if I divide delivery functionality, then only delivery management team would be responsible to handle the delivery management functionality. And if it is notification, only notifications team will be responsible to handle, to send push notifications or email notifications or marketing information to all the customers. So service-oriented architecture is kind of saying that instead of having this entire functionality, just make sure that you divide it into corresponding business-driven domains or modules. And each service, like order management service, has to expose its contract. Like if someone needs to call my service, here is my contract. You can call me at any point of time, but follow this contract. And I'm publishing the contract using WSTL, like using a SOAP protocol, it can publish the contract. And if someone needs to call, they can call the service endpoint. So there will be service provider, like order management, there will be service consumer, maybe could be UI or some other service. So whoever is being called is service, whoever is calling can have service, like client. So this kind of interaction would happen, but and do you know you need to know where the service provider and what's the IP address and all. And because in monolithic, everything is at one place. So it's kind of internal method calls are being happened. Like I can directly call order management class object dot something method to get that thing done. Or if I need to send a notification, I can call notification service dot send an email to send an email. But service-oriented architecture is not like that. It's kind of dividing this application and making sure more distributed in nature, not at one place. You can have your service provider at one data center. You can have one more service delivery management to one more data center. But you connect them with a registry broker. Like you're telling your services that you go and register with a registry so that if some client wants to really talk to you, I'll tell you details so that they will be able to talk to you and they will be able to make a call and get that corresponding details. So this is the basic architecture of how service-oriented architecture, but even it has some advantages and disadvantages. That's where we need microservices. So let's go to that advantages first. So as we are dividing them according to the domain driven or the functionality of business functionality, services are really kind of language. It became the language independent one because I can develop my own service in Go language or Python or C# or Java, whatever. I can pick whatever really the language really good enough to solve that issue. I can pick the corresponding language. And I don't need to deploy all the services closely together in a single data center. I can deploy wherever, like maybe in a more distributed nature.
Uday, you're muted.
Yeah. You're able to hear me right now.
Yes.
Yeah, sorry. Okay, so the loosely coupled will be can kind of brought down to the table because everything is unique. Each team would be working on their own corresponding functionalities and all. And service-oriented architecture also brings the reusability because service can call directly another service, or if it's something functionality and one needs to avoid a network call, it can embed the functionality of another service also in it. That's kind of reusing functionality instead of rewriting the code, entire code. It can or making a network call, you can really embed that code into the corresponding service itself. And definitely it brings a lot of agility because that brings a faster time to market. And because multiple teams are not working on a single source code, each team will have its own responsibilities to handle. No one is really stepping on each other's toes here. But what are the disadvantages? Like if everything is fine grain and everything is working well and we divided them, like what are the disadvantages of having an SOA? Similar to monolithic, as long as your service is small enough, there are no issues, at least no issues at some context. But again, services can also be becoming larger. If you're adding more functionality to your order management team, handle all the inventory stuff and all, making sure auto is going to place them, and a lot of functionalities you're adding to that. And if it is large enough, then again, whatever the issues what I told in the monolithic would also surface out here as well. And also service-oriented architecture, fundamentally, it uses single database, even though we are dividing services on a model-driven design, but still it uses all the service-oriented architecture services gonna use same data storage. Maybe it could be a NoSQL or SQL relational database. So they're going to rely on single database. So that will impact the latency issues, or could cause deadlocks if two services are trying to act on a single table, single common table. And this SYA is mostly built, uses either SOAP protocol or uses ESB, Enterprise Service Bus, to interact. And that's kind of SOAP is really heavyweight and all. And also it supports only XML-based communication. If you all know about REST API, you have different MIME formats like application/JSON you can send, application XML you can send, or file you can upload. There are a lot of formats you can send. You can communicate over REST endpoint, REST protocol. But whereas SOAP protocol supports XML only, and it's kind of heavyweight. So with this heavyweight SOAP protocol communications, SOA is kind of no longer kind of viable thing to have a to pick for a service architecture. And it's kind of less flexible also, because of the XML things I told. And ESB is it's called the Enterprise Service Bus. And someone is really calling out erroneous service bus as well. So because of that complex functionality, each service is really interacting with it. It's no longer recommended for large projects. And because of SOAP protocol, and we have REST is also evolved, gRPC is also evolved. It's no longer recommended to have service interacting with that protocol itself. Okay. And yeah, now with these disadvantages, then we need something to address the shortcomings. Like SOA evolved really to talk about to avoid the shortcomings of monolithic, and SOA also having some shortcomings. We need some system to be in place and to address all the issues of SOA. And that's where the microservices architecture really evolved. Okay. And before I give any introduction or any concept about microservices, I'll give you a poll and maybe give your answers, and maybe based on the answers, we can move ahead. Let me know once you are all able to see this.
We can.
Thank you.
I think that we have most part of participants answered.
Okay, so let me end the poll. So yeah, I'm going to, so most of them answered yes, like we can have multiple language, you can build microservices using multiple languages. Yes, you're all right. You can pick whatever the language you can, and each microservice can have its own language independency. And maybe you can get this question, why? Because of having SOA is really there, and what really microservices would bring up to the table, because it's also might be coming into some kind of issues. But before going to all those things, let's formally define it. What is exactly a microservice? So you can call it as a microservice whenever it's really small enough and it's autonomous, and maybe it's working with other services, and it kind of modeled on a business domain. So from monolithic and to microservice, everything should be small. That's where microservice is in place. And it should do only one task at a time. It should not do multiple things. Because if you are keep adding multiple functionalities, that's where monolithic and SOA failed, and we don't want that to happen again. That's why strictly we are focusing on it should be small enough and it should do only one thing. It should target to only one thing. And maybe if it is doing only one thing, and if there are other services are also in place, it should work together with other services, and so that we can build a good product out there. That's where this microservice architecture is aim is also for, and that's how these architectures really evolved. So first place, we have entire complex, tightly coupled monolithic is there. And because of its shortcoming, we kind of, even though we divided that functionality into business domain driven pieces, like order management team and delivery, notification, inventory, like that, still it is not small enough. And we had to go for microservices architecture, like still reduce the functionality of like whatever the targeted domain, business domain, so that it can be easily handled by the team itself. And whatever the issues which were brought up in monolithic and SOA would not surface out again. But maybe based on the diagram, you might get this thought like, okay, we need to make it small, but how small is really small, right? Should I, maybe it is not small enough? Should we need to divide that into one more small thing? And what is small in a quantifying thing? Like when can I call it just small enough? So when can you call it just small really is? Maybe when you are really able to build that microservice in 7 days, within 7 days, can you call it as a small microservice? Or if a microservice has maybe 100 lines of code, then can you call it as a small microservice? Is it small enough to hold? There's no formal definition for it. Small is a kind of perception based. Like as long as your team is able to hold it, is team able to manage it well, and if your QA team is also able to validate the changes, and if it's doing only one thing, as discussed in the definition, then it is small. Whenever you are about to breach that thing, then definitely it's not small enough. So you need to divide it and make sure you build another microservice. Okay, and yeah, and so if I given a service, and can you call it as a microservice? Yes, only when it has all these characteristics. It should be lightweight and independent and loosely coupled. Obviously, it will be loosely coupled because I'm going to divide based on the business domain. And it should be independent and it's doing only work like maybe order management service. If I don't have much functionality, I'll have only one microservice for order management. Or maybe notification service. It is sending push notifications to mobile or it's sending email notifications. I don't want to handle both of them in a single microservice. I want to do, okay, let's do push notification service. I create a new one. And email service, it's just responsible to send only emails. So there are two different services interacting with other services in order to build a product here. And as SVA was using a single database to interact, causing all the latency or deadlocks or issues kind of thing, microservices moved away from it. And it is recommending that if you are really building an ideal microservice, have your own DB or have your own code base also. Okay, don't combine that, like don't share the database. You can with some modifications, like a lot of principles in place, but still not encouraged to have your own DB and have your own code base as well. Don't combine your code with other microservices. Each microservice should have its own code repo, and all the functionalities developed by the team would be going into that repo only. And similarly, the DevOps plan, like deployment pipeline as well. Earlier, if you see that diagram, if you remember the diagram of monolithic, where one pipeline was there to handle all the traffic of different teams, where we should not be run into that situation again. So here we need a different deployment pipeline here to handle that entire that microservice load itself. And as discussed earlier, it should be microservice, should be autonomous, means it should follow single responsibility principle. If I have my email notification service, the primary job of that should be sending only emails. It shouldn't do anything. It should not do push notification. It should not check the order status. It should not send a delivery order details. So it should do only notifying customer or email. That's it. And obviously, because of the nature of microservices small enough and you can pick any language, that obviously building the technology heterogeneity, you can pick whatever the technology you need to build that microservice. And luckily, with the rise of containerized environments and virtualization and this orchestration frameworks like Kubernetes and all, we can deploy microservices in a Docker in a containers and deploy them into Kubernetes and all. You can work with it. So microservices is recommending that if you are deploying your service, maybe deploy as kind of a batch, like a container itself, so that it's self-contained. It won't interact with any other services. If it won't expose its data to other services, it's kind of concrete and small enough. And in SOA, basically in monolithic, every other communication was happen within the service web server itself. You just need to make a mapper call. Whereas SOA evolved that no need to happen that my services are at any place. I can make a SOAP request or I can communicate with ESP. But again, those are heavyweight. So microservices is kind of going away with them and proposing that you can choose any lightweight protocols like Restore HTTP or gRPC or some lightweight protocols to communicate among the microservices. Don't follow the SOAP and all. Those are old and those are not ideal for microservice communication. And yeah, as I told earlier, it should be responsible to save the data into its own DB. Okay. And as it's doing the single responsibility for principle, it knows what to do and it should do that only. So we discussed about the microservices and their like what exactly microservices bring to the table. And we need to discuss about 12 factor. And what is exactly this 12 factor app is? There is a company called Heroku. It's a kind of containerized platform where you can build and deploy your cloud native apps into them with minimal changes. You don't need to spend a lot of time in making sure that it's deployment ready, and you don't need to do anything regarding the deployment. Most of the deployment things will be taken care by them itself. So when they were deploying building their such kind of system, they came up with some kind of criteria. If you want to have your app into our system to be maintained, you should follow some kind of rules or guidelines or recommendations so that it will be cloud native and it will work seamlessly. You won't be running into issues like maintainability or the locking scale. You won't be seeing issues of scalability and all. It should be reliable and small enough. But later, microservices community also adopted that 12-factor app. It's not solely only for the Heroku platform itself. Maybe if you can imbibe the rules of 12-factor app, what is the 12-factor rules given by the 12-factor Heroku community, if you can imbibe them into microservice, we can also march towards ideal microservice, because those rules are really good. Those are not really rules, kind of principles or guidelines or recommendations. So let's see what exactly those rules are. So yeah, on a brief thing, these are all the 12 rules. You don't need to memorize them. We'll be discussing one by one each, and we'll be talking about what is exactly from 1 to 12. So let's start from first thing, code base. So as we talked about in the monolithic and microservices as well, monolithic, everything is maintained a single thing, but microservices is recommending that each microservice should have its own code base. So if this team is really small, there won't be any issues. But what 12-factor is recommending really is you should have one code base. It's tracked in revision control, means some kind of source repo, some kind of version control system should be maintained. And these days we are following mostly GitHub or GitLab or Bitbucket, anything. You pick whatever you want. And but even though you have one source code repo, have your system to have many deploys. Like I have a source code repo and I'll connect that to a pipeline, deployment pipeline, maybe Jenkins or some kind of pipeline. But that should be building my code base for every time whenever someone is really making a commit, and it's creating a deploy, build, and pushing it to the corresponding environment, maybe dev, staging, QA, and production whenever it's nearly ready. And if it is really maintained, then that's in that way really. So then uh, if you want to deploy into developer, someone is a new developer comes and setting up the mission, you can simply clone the chain code of that corresponding service. Maybe if I'm working on email notification service, as I explained, I can simply pick that service. I can clone from the version control, and I can get all the changes required, and I can spin up the application without minimal changes. And it's recommending that don't keep multiple services code into single source code repo, because you know, it's kind of difficult in from the deployment pipeline as well, and the code as well. Like again, if you're building two microservices code into single source code repo, merge conflicts would be more. And you can't really, you need to understand clearly what's really happening with the system, other system microservice before making your changes. And you need to make some configuration changes on the deployment pipeline properly to make sure that you're building your own corresponding changes into the corresponding jar. So to avoid all those things, you should have every microservice should have one code base, and that's anyhow microservices architecture is also recommending. And yeah, that's it with the code base. And the next thing is about dependencies. So whenever you're dealing with, if a microservice is dealing with dependencies, obviously uh, it needs to some assume that if I'm building my microservice with a Spring Boot application, so then I need to have Spring Boot related dependencies in my application. So or I need to have some kind of if I'm using GraphQL, I need to inject the dependency. If I'm using some Spring caching, I need to use that caching dependency. So everything, if I'm whatever I need as a dependency, I can't ship it with the application itself. Like I can't directly include them in the application. You should declare it. So, but the build system, whoever is really building it, should be able to create a jar out of it. Like I think you might have done, you might be doing this already. There are build systems like Maven and Gradle, it can take care of that. If you're using Spring Boot, maybe just Spring Boot, you just say form.xml. If you're using Maven, you define your dependencies in it. Or if it is Gradle, it's just a YAML file, give your all your configurations in it. So the build system is going to pull the configurations. Okay, your application needs caching, your application needs GraphQL, your application needs maybe Redis cluster configuration driver kind of thing. So let me pull out all those configurations from a Artifactory repository. So whatever the dependencies your app needs, push them into one Artifactory repository like JFrog and all, or a open source one also. We have one like kind of Bintra is open source one. You can use that also. So have your dependencies in an Artifactory repository instead of having them into your code, because it's hardly maintained the revisions and all. And let your build system takes that from the repo and prepares a jar or var according to the functionality. Now, these days we are mostly going with jar. So executable jar and all, it will take care of it, but don't ship anything with your application itself. And that will become for the new developers joining to the team as well, because they don't have to do anything. They don't have to download anything from anywhere else. They simply open up the application, run the mvn clean install command that would download each and every dependency from the Artifactory and prepares an image to be able to run and execute. Yeah. So, and the next point is the configuration. So what is exactly config? Is it the dependency is a config? No, it's not. Like config is something the application depends on. If it is interacting with if it is interacting with any other resources, so everything is a conflict. Like if my application is trying to save some image data into Amazon S3 bucket, so and then I need something of Amazon S3 route URL in order to save that. Or if I'm calling external API in order to authenticate or in order to communicate with our other microservice, I need that other microservice URL, username, password, everything. So this is config. Or if I'm connecting to a in-memory database, I need URL of the in-memory database. Or if I'm connecting with MySQL or Postgres, I need the DB URL and their credentials. So everything, whatever the app is interacting with, and it is their resources names and all the URLs, and these are all configurations. And the app needs to know them in order to interact with them. So that where can I say keep them? If my application needs this kind of configuration, where can I keep them? So I need to keep them. Can I keep them with the application itself? No, it's not. It's not recommended to keep the application. We keep the application because these are all dynamic in nature, because my password is going to change from that S3 Amazon S3 bucket URL might change from environment to environment. Dev, it might have one URL. QA, it might have different, and production, it might have different URL. Similarly, the credentials might change from dev. MySQL have one set of credentials in dev, maybe different set in production. Or can I keep them in plain text? If I'm keeping credentials in the plain text and then pushing them into source code as GitHub, so that's going to kind of create complex issues. Like we should not really keep plain text passwords into the GitHub source code repo so that anyone could read it and they would be able to connect and they can do whatever they want. It's not recommended. Then where can I keep my config? I can't keep with the application. I can't keep it as a plain text, and I can't. So where should I exactly keep, and is there any way to recommend that? And before we talk on that, I'll start another poll, and let's see we can answer that. Yep. Here is our poll. Okay, I think most of them answered. Let me end the poll and share the results here. So most of them answered all of the above, and some of them answered Git, and they picked Azure and Kubernetes config map. All of the above would be the right answer, because you can have a config server keeping all the configurations in a GitHub repo. You can push them into GitHub repo and connect with config server and tell to your Spring Boot application to pull the configuration from the Spring Boot config server. You can do that. And if you are deploying your applications into Azure, Azure provides a capability called Key Vault, where you can save them. Only your application would be able to retrieve it by referencing with a variable name. Similarly, Kubernetes also provides that kind of configuration through config map. Similar thing you can achieve with the Spring Boot auto-varying concept. As we are doing, we can able to do all those things. Yep, all of the above would be the right option. So yeah, so as we discussed, so we can save GitHub repo, we can save Azure Key Vault, like AWS. If you pick AWS, also AWS have similar set of tool, I think so. I don't remember exactly what's the name of it, but if each cloud provider has its own set of Key Vault kind of thing, or if you are really deploying your service into Kubernetes, Azure provides Azure Kubernetes engine, and AWS also have such set of setup. So definitely you can use of their config map of Kubernetes in order to save your configuration, but make sure you don't ship them with your application. And the next thing is treat your backing services as resources. Like we already discussed about the back services, like my app can interact with MySQL, it can interact with the in-memory DB or caching DB like MongoDB or etcd, anything. NoSQL DB, or it can interact with Redis or etcd or anything, Cassandra, whatever. So if anything is external And if my app is really needs to interact, treat them as a resources, kind of pluggable resources. I can now, if I need to plug MySQL, yes, I can be able to plug them. If my app needs to remove from move away from MySQL and embrace Postgres, app should be able to do that with a minimal changes. I think if you are all aware of Spring Boot, like beautifully, elegantly supporting that with a concept of data source configuration. If you configure that in the application.yaml file, so it would automatically creates the data source and able to connect with that corresponding source. It happens with all other caching in-memory databases or NoSQL databases as well. So you treat them as resources and kind of decoupled in nature. And whenever you wanted to move away from one, you can easily move away from that. And don't directly couple them into the application, but make sure you treat them as resources so that you can easily scale them. If I want only my MongoDB needs to be scaled, I need 3 instances of MongoDB in order to have the traffic, in order to service the traffic. Yes, you can do that. You don't need to affect the application. If you want to have a Redis cluster of 6 instances to service all the load, yes, you can increase the cluster without affecting the application, because those are all pluggable resources. You're not affecting the application code and anything. You're just making changes on the resources part. And this is talking about the deployment pipeline. We should strictly have separate build and run stages. Like whatever you're trying to develop and deploy into production in microservice, it should be deployed through the pipeline itself. Like assume that I made changes and deploy into production, and I need to change some configuration or some code in the production. Can I go directly connect to the production environment and make the changes there, and so that it will be ready there itself, so that I don't need to go with the production deployment cycle and all? That's not encourageable. Whatever the change anyone is really making, if someone is really making the code changes, it should go through this process of, it should build should prepare an image of it, like a jar or kind of thing. We should be releasing it and running in the production. So releasing means it will be creating a new branch for your changes, creating a build out of it and deploying it to the corresponding environment, and needs to be run there as the executable jar and all. But what will happen if you change something in the production on the fly without really pushing your changes into GitHub repo? Then definitely you'll be losing the changes. No one will be able to really to track the changes. So every code change, every configuration change should be done through GitHub repo. GitHub repo is the source of truth we should maintain, and it should run through build, release, and all. And each release, like you can maintain that each release should have its own release ID, so that if you want to roll it back and something bad happens, and you want to roll it back, and you can roll it back to the previous good working version very easily using the version number and all. So make sure you have your pipeline should have these kind of build and run stages, and follow them. And the next important thing is treat your microservice as a process, and make sure it doesn't have any sticky sessions. So what is really sticky sessions? Like assume that if you're running your microservice in a web server environment, if you're exposed to the API for the consumers or clients to call in order to service the requests. So you can't expect that, like assume that if you have 3 instances of microservices running in a cloud environment or somewhere in the Kubernetes or somewhere, any client request would be forwarded to any of these pod. Maybe if client C1 is making a request, that request would go to instance 1 or pod 1. Client C2 request would go to instance 2 or pod 2. If the client is making another request from the same client, C1 is making another request, you should not expect that request should go to I1 or instance 1 pod 1 again. Because though there is no guarantee that if the previous request went to instance 1 or pod 1, the next request from the same client would go to that same client instance only to service. You don't expect that, and don't write your code in such a way that, yeah, if I have a session, I'll keep a session on the client cookie on the client, the kind of session persistence, so that whenever I'm receiving a request from the client, I'll forward it to the same instance. So 12 factor app is not recommending that because these are all parts. Parts can die anytime. A new parts can spin up any point of time because of various reasons, network issues or memory issues or more CPU usage and all. These container orchestration systems like Kubernetes and all handle it gracefully. Whenever you expect that system to have only 3 parts at a time, if one of the pod is really behaving odd, it will take down that and spin up another pod without you noticing anything on anything physically. Your application doesn't need to really manage about anything. Orchestrator should be really taking care of that. But if you write such code expecting that the consecutive requests in the same client should go to the same pod, but what if the pod goes down? You won't have any control on that thing. So make sure you don't write code and don't use the session persistence logic, anything. If you have such a requirement, something like that, try to save the data into in-memory data or some kind of Redis or etc. them and or persist them. Basically, your app should persist into the in-memory or DB. Even if some other client is saying another request, based on the request ID and check the in-memory database or the normal database and get the information and proceed further. But don't expect that same session would be going through and same pod would be serviced again. And the next point, what we're going to discuss is the port binding. So each microservice, if it's running on a pod, it should export it saying that, hey, I'm running on this host under this port, because it needs to know if someone needs to call that microservice, it needs the URL to be called. But can a single host can have multiple services? Yes, you can deploy multiple services into a single host. So that host would be servicing 3 different microservices or 4 different microservices. But how can we differentiate the microservice from if we are deploying in a single microservice? Then port number is the differentiation. And if you are really building your applications in Spring Boot, you don't have to do anything because Spring Boot has a simple configuration called server and port, where you will define the port number. And as soon as it gets deployed into the corresponding host, your service will be registered and operating on that port itself. So if you see the example here on the diagram, we have 3 services, service A and B and C. They deployed on their host, different individual hosts, A underscore DN and all. But they're running under same port only here, 8080. But what if they all deployed into the one DNS, one host, then they should have their own unique port number so that the clients would be able to request them in order to get the service. And the next point, what we need to talk about is the concurrency. So what is really concurrency? Concurrency is nothing but if something is happening at the same time, or if you have multiple requests to be taken down synchronously, or asynchronously, we need some kind of process in place to handle all the large load of requests. Like assume that we have only one instance of web server to service all the requests. Until it receives maybe 10,000 requests, maybe it's fine. It can take one request at a time or it can receive the response. It can send the response back. What if it's receiving 10 lakh requests? Maybe if you don't have microservices on this concept of Kubernetes in place, we might need to build some threads or you might need to enhance your web server to accept multi-threading. But web server also has a limitation. Web server can't scale up to, can't service around 100,000 requests or 200,000 requests. It has also some limitations. It can also do only maybe 10,000 or 20,000 at a time. What if your requests are really time-consuming tasks? They're taking more time, and then your clients would feel that response latency and all, right? So that's when 12-factor app is recommending that if you're getting a concurrent request at a time, and if you want to service them same time and have the load, service the load and all, make sure you multiply them. That's where scaling is coming to picture. Scaling should be anything, it could be up or down. If you have more traffic, then increase your number of pods from 3 to 30. Or when your service is really not receiving any traffic, then bring back to them 3 again. Like I assume that if Flipkart is running a sale, a billion day scale sale kind of thing, they can't run their system with only 5 or 10 nodes. Definitely they will be expecting that at least they need 100 pods. The traffic is really huge. Maybe once after the 3 days or 4 days of sale is done, they don't want all the pods to maintain. Maybe again, the 5 or 10 pods is really enough. So have your system work as concurrent whenever really there is a need of business, or there is a need of concurrent requests and all. Then you do that scaling thing and bring back them. This is called auto scale. We call it as auto scaling. But have your system make it elastic so that it can be able to service all the requests. So can I scale only web requests, web servers? No, no need to. Like if you assume that if you have a microservice which is reading from a pub subtopic or a event hub topic and doing some task, that you can call it as a worker. It's not really web. It's not really doing any web functionality. It's not exposing any REST endpoint and exposing it and servicing the request over REST. Maybe just receiving the topic message on the topic and doing some task and acknowledging that message back. So, but what if your pub sub topic is receiving 100K messages? If you have only 3 nodes subscribing to the topic and processing all the messages, right? Those might not be efficient. Like assume that you are sending a marketing email to all of your customers. If your customers are around 1 crore or 2 crores, running 3 pods, reading from the topic, message by message, sending a SMTP email would not work. It work, but it will work, but it might take an hours of time. You might not be able to send the marketing promotional information within an hour, within half an hour kind of thing. But how can you do that? Like in such situations happens, especially GCP offers PubSub based data scaling, where you can configure parts that whenever my PubSub topic has more than these messages, then auto scale your pods. Similarly, you can have scheduler, some kind of scheduler functionality. You can have schedulers also in your code. You can scale them according to the application itself. According to the need, you can scale them, or according to when your need is done, scale down them back again. Yeah, this is a really important point when it comes to reliability. Make sure you bring the robustness of this application with fast startup and graceful shutdown. Like if you're building your microservice using any architectural technology like Spring Boot and all, Spring Boot generally takes some time to start up because of its several agents. Reflection is one among them. I won't be talking about that, but it will take some time to start up. And maybe once it's start up, it needs to have a DB connection in order to interact the DB. It needs to have a connection with NoSQL, maybe to save something in memory, or it needs to have some kind of connection with some S3 server in order to save some or retrieve some data from the Amazon S3 bucket. So in its lifetime, the pod is making connections to some resources. But what about those connections when it's really going down? Like assume that if it's working, the app is up and running, the pod is up and running, someone is trying to redeploy some changes, or it got a signal from Kubernetes itself that you should go down and the pod is up and run, should be up and running. So what should we do with those connections? Should it be directly close itself, shut down itself without really closing the connections? It should not happen. So it should be gracefully shutting down whatever the task it's really doing. Like if it is processing some number of requests, it should stop whenever it receives a deployment signal, a stop signal from the corresponding orchestrator. It should save the state into the DB. Okay, till now I'm done. I did process these many things, and then I'm going down. So the next part, whoever is really spinning up, will take the data from there itself, will resume the operation from the last where it's really stopped and proceed further. So make sure you bring that capability by doing some kind of things in Spring Boot, so that your microservice will be really reliable and graceful shutdown will happen, and your resources connections won't be really living in the air. And this is called dev prod parity. This is really necessary for a developer. Like you always, maybe if you are a developer in the team current call today, most of them would say that my code works in my machine, but it won't work the same way in production, because you might be using a different configuration in the environment, and production might have a different configuration. You might be using a open source SMTP server to send emails in your local. Production might have you using some Windows SMTP server, something like, or a SendGrid third party to send the email notifications. So if you don't the same environment similar to production or other environments in your developer local, or if you're running in a dev environment, then these kind of issues would happen. So make sure that whatever the changes you're doing, and if you're validating them in the dev environment should be closely related to whatever the production it is, so that all these gaps would be resolved. And if your code is working well in dev, definitely it will work in production also without any issue. And this is one of the most important point, and that is logs. Treat your logs as event streams. Log is kind of fundamental thing. It will tell you about what exactly your app is doing at that point, and is it really throwing issues, or is it throwing null point exceptions, or is it throwing in out of memory exceptions, or is it really processing the issues fine? So all these things you can figure out from the logs itself. But before the microservices and service and architecture, if it is single app, so generally you can push your logs into the corresponding web server code. You can go to the server and view the logs and all. But if with the adoption of containerization and this orchestration frameworks like Kubernetes and all, every pod is doing something and every pod is producing logs. Then how can I see the logs of the pod? Should I log into each pod and view the logs? Is it possible? The pod life also kind of really less. Maybe it may be up for 3 minutes or 1 hour. Then once the pod is down, what about the logs? Where can I see the logs? So what 12-factor app is really recommending is treat your logs as events and don't push them, keep them in the pod itself, push them to some centralized storage area, so that, and someone would be really spinning up a Kibana or Elasticsearch on top of it, and they would be consuming the logs for troubleshooting purpose. But don't keep them logs with you. And the last factor, it is admin processes under 12-factor app is, if you are doing any administrative task, like maybe if you have a microservice, but you need to do some data migration stuff, or loading the data into the DB monthly once or weekly once kind of thing, or you have to run some one kind of batch stuff every daily once. So don't ship them also along with your app, because that's a different thing. We got microservice, as microservice is saying single responsibility, it should not do multiple things. You need to divide that into a separate process, have its own repository, you can call it as a bad job, you have that code with it, so that your microservice is really clean and clear and what it does. If you have any such administrative task, have it as a one-off process, but don't combine them with your microservice. And these are all the 12 factors are really needed in order to effectively write a microservice which doesn't resolve any issues, which reduce most of the issues. Yes. But the next slide we want to talk about, is it the 12 factor is the only thing that we can, if we follow these 12 rules, then are we good enough? Mostly good enough, but again, there are some things we can talk about other than beyond 12-factor rule. There are 3 more rules. If we can imbibe them, recently the tech community also brought up these things. If you can imbibe these 3 also, we can definitely achieve or reduce a lot of noise, and we can achieve good performance of the application, reliable and robustness application. And those are API first and telemetry and authentication and authorization. So API first strategy is the really good one whenever if you are exposing your API over REST protocol, and if you're expecting that other services to be able to consume and call, you need to set the contract. But how can you set the contract? You'll share the contract In SOP protocol uses the WSDL thing to share contract, but rest uses the URL structure and all that recommended path params and request params and all. But how can you share the contract with other team? You get the confirmation from the team, if whoever really wants to consume it, and make sure you share the contract before really doing the development. So you can use Swagger or OpenAPI protocols in order to build that contract first, get your business feedback, and then you start developing it. Once everything is confirmed, start developing it. Instead of directly developing the code and publishing a contract, then your client says, no, but I need one more parameter to be passed in order to get the thing. Then it should be rework. In order to avoid the rework, have your design your API first, and then code it based on the confirmation. And then the next important thing, this is a really important thing if you want to troubleshoot your application or understand what happens with your application. If it's going down at some point, what really happening at that time? Was it because of the traffic, or your application is taking a lot of time to process everything? We will be knowing by telemetry itself. So telemetry is the one, it can tell you about your health checks, your request patterns, number of requests received, or number of messages processed and all. Everything, if you using Prometheus or Grafana dashboards, have them into a alerting system in place, you can really figure out and troubleshoot them. So make sure you have one of them. And the final thing in the beyond 12 factor thing is authentication and authorization. So don't let any unauthorized user access your application without any proper verification. Have some role-based access. So if a role with admin should be doing all the things, other roles should not be able to do all the corresponding things. Maybe you can introduce JWT tokens or OAuth, or have a API gateway in between to authenticate and authorize your microservice request. But don't expose any of your API without any of them. That would lead into a lot of security issues. Yeah. So now this slide, we're going to talk about the initial problem, what we discussed with monolith, what was the problem there, and how microservices really coming to rescue this. Okay. And even if you have multiple teams, like what we discussed, order and restaurant and delivery, as microservices recommend to have a single source code repo, order management would be working on its own repo, and microservices is recommending that. And one more thing is it should have its own pipeline. So what are the code order management team is pushing to order service code will be deployed or built by that corresponding web deployment pipeline, and it's going to deploy into the corresponding web environment, like servers, web servers. And similarly, if each team is working parallelly on its own DB, no one is really touching on their other stores, and no point of major conflicts would happen. The deployment pipeline also won't be busy. All those issues what we discussed with monolith and SYA won't be serviced out here until your application is not big enough. Yeah. So now, so what are all, like, assume that if I'm building the service microservices, doing only one part of the thing, if I'm building around 3 or 4 microservices or 50 microservices, how can these microservices communicate among themselves? What are the different ways it can communicate? There are possibly 2 ways: synchronous and asynchronous. Synchronous means you're sending a request. If you're a client and sending a request to another service, and you're expecting a response synchronously, and the connection, whatever you're making to get the response, will be valid until you get the response, or you'll get timeouts and all. But if you're in a situation where, for example, this example, if you're making a request, if you're adding an item to the basket and you're ordering it, and basket service should call ordering service should let the call catalog service or inventory service to tell that yes, he's ordering, so remove one item from inventory, or send one more send to shipment service, make sure that order gets shipped within time. There are a lot of chains would happen, and if you are trying to do that with synchronous protocol, that's an anti-pattern thing at that case. So make sure if you are doing the microservice communication, try to follow the event-driven or asynchronous protocol, where communication among services would happen through events or messages, pubs of topic or message to have an interface in between, instead of directly sending if one of the client is calling a microservice, the client no need to wait until every response is done. it's kind of asynchronous. Once everything is processed, the client would get the feedback using a webhook or some kind of response we can use over HTTP. So always don't use synchronous response. Go with asynchronous. Yeah, maybe we'll take some time to discuss about how a general microservice architecture we're gonna build. If you're really building a simple e-commerce application and on a website, on a mobile app and all. So everything should be authenticated using an API gateway or using BFF pattern. Like authentication and authorization we discussed about in the beyond 12 factor thing. So it should be authenticated, properly authenticated, and each service should do only one job, single responsibility thing. So that's where we built here catalog microservice to list out all the products, and it should have its own DB. So that's where catalog server is maintaining its own DB, and similarly, ordering microservice takes care of orders, and it's also its in Ruby. It's not interacting with catalog at all. Every service is having its own perimeter so that it won't be interacting with colliding with their functionality. Similarly, each service, if you're interacting with it, whenever they are done, if they need to interact with other services, they're posting the updates to a common event bus or event hub so that assume that whenever the order is placed, it needs to let the shipping service know that shipping needs to start. Then it won't directly call the shipping service. It will post the event into the event bus, and your delivery or shipping service would be listening to the event bus to see whenever the event happens on that, intelligence on that, and process the request like that, so that it's all event driven in nature, and make sure you imbibe that event driven architecture into your microservice without following that synchronous we explained, so that you can architect this kind of solutions very easily and keep your microservice small enough. I won't take much time to talk about the benefits because we all have gone through all the things here. If it is small enough microservice, definitely your deployment pipelines will not take much time. You can easily maintain them, you can deploy them, and you can scale them, bring back and down. And we already explained about technology heterogeneity and all. But this is the most important point, is fault isolation thing. Like if one of the microservice is really facing issue, you can go ahead and fix that microservice itself, so that that won't impact other microservice. Like assume that delivery microservice is not working well, there is other microservice like order and basket microservice or catalog microservice won't affect. Maybe the delivery will be only thing affected. You can go ahead and fix it, or you can roll back to the previous release to make sure that your customers won't be affected. And this is really a good thing with microservices. But does it everything green with this microservices? Everything works well. If you are using microservices, we don't have any disadvantages or concerns. Yes, we have. We have some of the disadvantages also with microservices. And these are all, like, if you don't know what are the disadvantages and trying to imbibe microservices everywhere, then definitely it's going to be having an issue. Same thing like SOA, if you keep adding new functionality and if you're not doing single responsibility principles and all, it's going to cause a lot of issues. And with microservices, if you are deploying a feature which spans across multiple microservices, it's really difficult. Like assume that if you have a feature that needs to be taken care from order and basket service, they need to make sure that both the teams are deploying services same time, or the coordination has to be there. Otherwise, one service is deployed, another service is not, then UAS will be running into issues. And distributed service are always harder to debug. Like you should have proper systems like tracing and all in order to see the communication. Like if order is really not placed properly, like they need to identify what is the issue. Is it issue with the basket service or catalog service or some API gateway at end, or is it issue with the order management service? You need to identify. It will take some time, but you can easily identify that using having a tracing pattern implemented. And the latency also could be more here, because if you are building multiple microservices and everything is being communicated over synchronous or asynchronous, that's network call, because microservice itself is bringing up that location independency. That's also causing the higher latency. If it is monolithic, everything is at one place, you don't have the charge of network call. You can simply directly call that class.object. But whereas this microservice architecture is being location independent and pods and all, that will cause some latency. And this communication of microservices also brings some complexity. You have to have some service discovery. You need to make sure that load balancing and all, lot of things, and which I'm not going to talk about today. We have a separate session to talk about all these patterns and these issues. But on a broad overview, these microservices have these kind of concerns. So make sure you deal with them properly. Otherwise, again, we'll be running into the same monolithic hell what we discussed. So I'm going to end with this kind of someone case study recently happened. Recently MicroService, Amazon Prime kind of published an article saying that they moved into monolithic, and that brought a debate in the tech forum, that community, that monolithic is microservice is gone, end of microservices, monolithic era is coming up again, and serverless is gone. A lot of people talked about that, but let me talk about what exactly happened and what really Amazon Prime Video did in this case. Did they really move away from microservices and embrace the monolith and all? We can discuss that. So I think most of you might have used Prime Video, you might have seen videos on it. So in order to have efficient stream of video streaming and all, they have some monitoring service to monitor and make if there are any frozen video bytes or corrupted video bytes. To track that, they have a media conversion service that will stream the video and convert into bytes, kind of bits, chunks and the kind of thing, and they'll keep them into Amazon S3. Whenever it does, it sends a notification to AWS Lambda, where they orchestrated a workflow using step functions. And each step function will be triggered, and they will read from the Amazon S3, and that maybe one would be checking the Trojan thing, other would be checking the corruption of the byte corresponding stream chunk. Once they're done with the chunks, they'll aggregate that video and give it into the AWS Lambda aggregator, and this Lambda is responsible to save into S3. So here, everything is kind of a notifying thing, kind of event-driven thing. Lambda and step functions and media conversion service, everyone is really able to communicate over event-driven thing to achieve the single common thing that they need to verify is video streaming, whether it's corrupted or frozen or not. But what really happened during the time that would cost around more, like, this AWS serverless component, the step functions and lambdas are like, that will be charged for every invocation. And you are streaming a lot of videos and you're trying to convert them and saving them in S3. So you're telling that, yep, 1 byte, you're converting entire stream into a series of chunks, saving each chunk into S3. Each chunk would be notifying a Lambda, and that would orchestrate a workflow of two step functions. So for every chunk, your 2 state functions are being called. That is causing a lot of building for the Amazon. So they revised it. So then they thought through and see, is it the proper solution? Is it what we want? How can we reduce the cost? Because we made it in serverless, and we did build, and within less time we orchestrated workflow. We have step functions which are scaling well, which are doing fine without an issue. Even if we are increasing more number of streams, they were able to cope up well and doing the work. But what is really costing here? The costing here is done because of the Amazon step functions, or workflow orchestrators basically. So then clearly, if you see here, everything is a function here. This is all a single function, even though they have different components together, but really what they are achieving towards the functional single responsibility is they have a media conversion service, which is the functionality is to make sure their video stream is out of detections, out of frozen issues, out of corrupted frames. That's what they need to do. They don't have to have a pure event-driven stuff in order to verify this. So then what they did is, then they figured out that let's do that. As we know that this service has a boundary, and it says kind of microservice. Let's have all the components together in a Amazon Elastic Container Service task, so that my media converter will be there. Instead of direct notifying them, saving them into S3 and notifying them over orchestrator Lambda workflow, whenever I'm converting the chunks, I'll be calling them directly. I will be calling the detector pieces. So that I would eliminate the step functions to be called every time. And once they are done, they'll be aggregating and saving into the in-memory DB. And then finally, they will be saved into S3. So that every time these step functions no need to be called, and aggregations and all this cost will be reduced. They were able to reduce the cost by 90%. So this case study is going to recommend you that like microservices or serverless components is not ideal for each and every scenario. And if you have your architecture built on microservices serverless, please revisit from time to time, or whenever you are making a breaking change, or if you're making some changes, architecture changes, use telemetry to make sure what are the costs are and whatever your application is really behaving well or not, and revisit your architecture. And if needed, sometimes these kind of tweaking needs to happen. You need to migrate. If you really, maybe if you divided them really small, and if you don't want that to happen, you can again bring back them together into a single microservice unless it's doing single responsibility. And yeah, so it's time for Q&A. And I think I have some questions on chat.
Yes, you have questions in the chat.
I think Sanjeev, your question is regarding ERP systems and CMS. Yeah, I think Chandra already answered that question. So even though some of the systems like that ESBs, they are still using the monolithic only. Chandra mentioned they will be using the vertical scaling. I explained also. Some of the things you can do with vertical scaling, but horizontal scaling also possible. But again, that's kind of reactive thing. They have to have capital expenditure in place, have the servers in place in order to have the load. But you're kind of maintaining the servers even if you don't have the load. You don't have the capability of auto scaling also in that. In the old things, monolithic things, you can't bring back the scale down immediately. So that's kind of expenditure cost and all. So luckily with the virtualization stuff, microservices adopted that auto scaling feature. So that's where I think, is it bad design to have stateful microservices in distribution? So here you think that's kind of a debating thing. Application should be stateless because it should not have anything with it. Whatever the data is processing, it should be keep persisting to it. Because what if the pod goes down all of a sudden? It's somewhat crashed. And what if you're processing a bunch of messages from a sub topic? How can you share the load with others? And how can the other pods know that you processed 100 messages already and they need to take care of the remaining 100 or remaining 100K? So it should not persist and keep anything state with it. And you should not expect that the session persistence also should come along with it. Whatever it's interacting, it should be keeping into either into in-memory, fetch the data from the in-memory caching DB, or fetch the data from the memory, the database itself, read from it, or S3 or whatever. Have some kind of memory thing, read from it, and then proceed ahead with it. But don't make sure you save anything into your app itself, so that there is a danger of it's going down at any point of time. Hope that answers your question, Sanjeev.
Yes, Udaya. Thank you.
Yeah, I think you might have answered all questions. Like, do you have any further questions?
If someone wants to ask a question, you can unmute now and ask it by voice. Have you read like last question in the chat?
I'm checking in that now. So in SOA, we share basic components. I didn't get your question, Afridi, but I think basic components means you're talking about the DB and all. Yeah, it's kind of, yes, we need to share, the SOA shares some of the basic things like DB and all, but that's where if the team is really small enough, that's okay. But if you're adding more complex functionality, as I explained, that's kind of hard to evolve. And also you can't scale, like I explained, right? Like assume that one of microservice is really using a caching DB and you want to scale the DB only, you can scale it if that microservice is really expecting more load. Or else if two microservices are really reading from one common DB, okay, what if one service is really dumping a lot of data, inserting a lot of load into that DB, but what about the other microservice? This performance impact, this second service also would impact some performance implications because of first service is really using it huge, and it can't really give the good service response to its customers. So these days, response latency is pivotal, and we want our service to respond within less time. But how can we do that? If our service is using only the corresponding perimeter and no other services are really affecting my resources, then I'm okay. Does it cost more? Yes, it does. But again, it ultimately, if the response latency is the one thing and maintainability is one thing that you want to achieve, then yeah, it needs to have. And do we have any questions?
We have update in the chat.
Okay, one more question.
And one more question.
We want to dip in the both order DB and product DB at the same time. Yeah, that's all kind of different strategies of like we need to discuss about different patterns are there, like CQRS and event-driven strategies we need to discuss. Then we can clearly discuss about that point. I think it's not the right time to discuss. But that's a good question. So what are the strategies for managing long-running decision processing across multiple microservices? So yeah, if you have a long-running applications, like processing things you wanted to do, definitely you go for worker applications instead of exposing them over REST API. And maybe you can introduce webhooks, and whenever your client calls you, take their response and notify them that I'm doing it, but I'll let you know once I'm done. And have your long-run task running in the background. Once that you're done with the process, you call your customer on that corresponding webhook and let them know that, hey, I'm done. Or you publish the status somewhere using event-driven. You'll send the email or you'll send some kind of notification channel to publish. But yes, even these worker threads you can use in order to efficiently have these long-running things.
Hi, Udaya.
Yes.
Yeah, just one question regarding the team size. So what is the ideal team size for a microservice app to be called as a small enough?
Yeah, that's again, that depends on the team as well, right? But ideally, most of the teams I've seen are like hardly have 5 to 7 developers mostly. But even if the team is really bigger and doing the complex thing, maybe they won't gel well and understand their functionality, whatever the products they are dealing with. The team should be really vigilant enough and just be autonomous and doing what exactly they are doing. They should know well, and they should have a goal towards their product. So I wouldn't say maybe 2 or 3 kind of thing. Maybe 5 or 7 is okay, kind of ideal, and it depends on the project too.
Right. Thanks.
What are the parameters can we consider while breaking the monolithic application into microservices?
Yeah, so parameters are nothing but mostly the business. We do business-based domain-driven design, model driven around the business functionality. Like assume that I have a complex functionality I need to divide into multiple microservices. So then based on the functionality, if you are using the e-commerce example I've taken earlier, or any complex functionality you'll take. So you understand the functionality first and gather them and figure out, okay, is this a single task and can I separate it and build a microservice? Maybe you don't do all at a time. You do one by one. Like let's take one piece of functionality that is a single thing that can be done by a single microservice. Let's remove that part and build the microservices standing aside with this monolithic, and integrate that microservice into your monolithic, call that microservice and make sure everything works well. And similarly, pick another functionality, which is really single thing again, and proceed further. And that's the only parameter. But other than that, if you're not doing with domain-driven design, definitely you'll be running into issues again. Hope that answers your question.
Yes, thank you.
Okay, if you don't have any questions for now, anyway, you will have opportunity to ask them maybe in the comments after we will share the recording. Yes, please tell us what is the next.
Yeah, we are done with this topic for now, but as I said earlier, we have a series of sessions planned, and this is the first session being giving introduction about microservices and their nature and all, when do we really need it. And we are planning for next sessions. So, and maybe probably in June, we will let you know. And please to like, share, and subscribe, and follow our LinkedIn, Facebook, and YouTube pages. And we will be posting our updates. And maybe in June, we are planning to have a session on what are the decision patterns really you need to have implemented microservices to cater different issues. And that's it from our side.
Uday, one question I have.
Sure.
May I?
Yeah, sure.
So if we are starting from scratch and we were asked by our architect, we should be moving towards a microservice architecture kind of thing. Is it a good idea to start with the microservice at the initial stage itself?
And I would recommend, like, it depends again, basically, if you are a startup company and if you need a faster market time to market thing, and if you don't know clearly whether your architecture really works or not and what kind of architecture would suit you well, I would recommend you guys to go with monolithic builder application, because monolithic would take much time. It won't give you the network latency won't be there. It won't take much time to build and validate the changes and all. It's pretty easy until it's small enough. Maybe once your startup idea works well and you are able to get more traction regarding from the customers and all, if you're able to do it well, and if you're not able to manage it at that point or at certain point, and when you figure that at that point if you need some kind of architecture change, then ideally it would go for microservices instead of starting from scratch. Whereas if you're something if you have a big company that you wanted to build a good product, and you know clearly what are all the functionalities, you have a clear boundaries of each and every functionality, then it's okay. But again, going straight away with microservices won't be the recommended thing when you're not sure about the functionalities or what kind of things you are going to achieve.
Sure. Thank you, Uday.
Can you please turn the previous slide with the social media?
Sure.
Now you have time to scan our social media QR codes and follow us, because we will post all the events on LinkedIn, Facebook, and also we'll post the recording at our YouTube channel, and in Instagram we also can find information about our technical speech. And thank you so much for this presentation. I think it was very interesting and very good to know. So if you don't have any questions, we all want to thank you for joining us, and please stay tuned and follow us to have updates.
Thank you all for your participation, guys.
Thank you. Have a nice day.